Alright, looking at chapter 2.3, as you notice there is no A or B on this, which means this is a one-day lesson. The good news for you is that there's no more official modeling necessary. I'm going to use it to explain a strategy in tomorrow's lesson, but you are out of the woods in terms of the foundational work that we have been doing last week. It is very important, though, that you get a firm grasp of solving as a concept in order for this week and the upcoming weeks to make sense. So let's just quickly review the basic rules that we learned so far. I'm going to pretty much use the modeling that we used to kind of discuss it. What I told you, for those of you who have had an issue of visualizing this, is that that equal sign is like a wall, and our objective is to get the variable alone. Well, the variable is getting a 6 added, so the way we offset that was by subtracting 6, bringing down x, that canceled out, and we also brought down a negative 17. And that was all we needed. Now, we did check that, which I'm not going to require as much, but just talking about the basic rules, that was one of them. Another rule, again, if this was our wall, our job here is to get rid of the 3, and the 3 is being divided, so what you're going to do is multiply both sides by 3. I hope you remember that. X comes down, these 3's cancel out, and 13 times 3 ends up as 39. You also had a problem that looked like this, where if this again was the wall, and the x alone, we had to get rid of this 3, which don't let the negative sign mess you up. That 3 is a positive 3, so what we had to do was subtract 3 from both sides. Do not forget to bring down a negative x, which we saw as like an upside down cup, and 4 minus 3 turned into 1. And the last thing we learned to do in that last week was that if x is negative, then we simply switch both sides and turn both sides over, ending up with negative 1 as our answer. And then the last basic one that we saw was if a number is directly attached to x indicating multiplication, that we get rid of it by dividing. And so you end up with x coming down because the 8's cancel out, and the answer it would be 6. A few more from last week that we got into was 2 steps. Again, visualizing this as a wall. What we said was that this was like 2 cups and 7 signs there. The weakest number here was the 7, and we want to move the weakest number first. And so we subtracted 7 from both sides, bringing down 2x, and 17 minus 7 was 10. Our second step was to get rid of the 2, which is being multiplied, by dividing both sides by 2, ending up with the answer of x equals 5. On this one over here, once again, x and 9 are in their own fraction, which means that they're obviously very close. The first number we want to get rid of, again being the weakest, is the 1. So we subtracted 1 from both sides, bringing down x over 1 equals, or sorry, x over 9 equals 9. And again, if this is x divided by 9, the way we get rid of that is by multiplying both sides by 9, getting x equals 81. And then the tricky one that we saw last week was the one where x and 2 are on top of a fraction with a number on the bottom. And what I told you is that this is not the weakest part, because those 2 are at least on the top part of the fraction. The 4 is actually the weaker number in this situation, in which the 4's cancel, bringing down x plus 2 and 28. And after that, you move your 2 as you were taught before, which is by subtracting 2, getting x equals 26. So that was pretty much what we saw all of last week. Outside of dealing with the negative x, those problems cover about 90% of what you've been exposed to so far. Today just incorporates the process of simplifying. So as long as you understand the distributive property and combine like terms, nothing challenging is really being added. Now, if you have had issues with the distributive property and combine like terms, that's probably going to be the source of your problems. That is, if you are already up to speed on your solving. So if solving hasn't been an issue for you, just be ready for the combining terms and the distributing, and you should be okay. The easiest way I will explain it to you is that you need to make sure that no side looks what we would call messy. And what I mean by that is no side should have any more than one variable. No side should have any more than one constant. And when we look at this problem here, problem number 1, on this left side we have a 3x and an 8x that can be put together. And so in order to clean that mess up, we're going to put them together and make that 11x plus 5 equals 27. And notice it looks just like the 2-step equations we did before, where the first thing we do is subtract 5, and the last thing we do is divide by 11. pretty much a lot of the problems are going to end the same. It's just a matter of making sure that you understand again how to deal with the mess. That is really the summary of today. The problems that you have today are only a step above what you saw last week because they make one side more messy or both sides more messy, and we have to clean them up first and then go from there. Alright. Problem 2, you can already see the mess when you look at it because we haven't solved anything with parentheses, which means obviously we want to distribute the negative 2. So again, the way we get rid of this mess is by distributing. We get negative 6x minus 18, which is where you need to be careful, equals 24. We then have to get rid of the 18 by adding it to both sides, getting negative 6x equals 24. 18 is 42. From there we have a negative 6, which my recommendation for you, especially with inequalities coming up, is to switch all the signs first and then divide by 6, getting x equals negative 7. So again, not so bad. Just make sure again you can deal with the combining like terms mess, which is one thing you're going to see. Another one's going to be the distributive property. For the most part, those are the only two obstacles you're going to see. As long as you're very careful with negatives and combining amounts, like I said, the negatives plus negatives and all that, it looks just like a two-step equation. One more type of problem exists, but I think it's better if I show you how the property works. Recall the bell ringer, I think it was in week 1, when I explained that when you multiply a whole number by a fraction, that the whole number goes to the top. That's what we're looking at here. So in some of the problems you're going to have fractions, and I need you to understand what happens when you multiply a fraction by a whole number. And what happens is the whole number multiplies to the top. So 5 times 3/5 becomes 15 over 5, which ends up as the answer 3. 8 times 5/8, 8 goes to the top, making it 40 over 8, which reduces to be the answer of, or simplifies to be the answer of 5. 7 times 6/7, the 7 goes to the top, making 42 over 7, which simplifies to be the answer of 6. I want you to notice, though, that the original numerator came out of each fraction. So if you look back up here, after I multiplied, I got the answer of 3, which was originally at the top. After I multiplied, I got the answer of 5, which was originally at the top. After I multiplied, I got the answer of 6, which was originally at the top. And what happened is, because the denominator canceled out with the numerator, so anytime your numerator or the number you're multiplying by matches your denominator, you honestly could have just crossed those out and got that answer. Alright, so some other examples real fast just to make sure you understand how that property expands a little bit. If I have 10 times 3 over 2, if you like doing 10 times 3 and then reducing that way, that's fine. But as you get further into math, it will help if you look and say 10 and 2 can both be divided by 2. That goes away. This turns into 5 and makes it 15. Again, 10 and 2 both divide by 2, so 2 goes away because it's gone. 10 divided by 2 is 5, and since that goes to the top, 5 times 3 is 15. Looking at this one, 8 and 4, both can be divided by 4. 8 turns into a 2, 4 goes away. Multiply your numbers, you end up with 6. 12 times 1/6, again, 12 and 6 can both be divided by 6. This turns into a 2, which multiplies here and makes your answer of 2. This process is important because this section also introduces us to fractional problems, and you'll need your skill of finding the common denominator or least common multiple. If you have not already developed it, let's just look at some examples. These are some other problems you're going to see on your work today. But again, don't let the fractions intimidate you. I think that they're very doable. You just have to make sure you keep in mind that we focus on what the denominator is. And here we have n over 12 plus 5 over 12 equals 8 over 12. Notice how all these have 12s on the bottom. And so what we can do is multiply all three terms by 12. And that's how I show it, is just by putting 12 on top of them. Remember that the top number and bottom number cancel. That comes down as n. Top and bottom number cancel. That comes down as 5. Top and bottom number cancel. That comes down as 8. And then we solve as usual. In this situation, our mess is the fractions. So remember I told you that the theme for the day is that you want to get rid of messes and then everything gets simple like it is down here. And a lot of solving works like that. As soon as you can clean up the mess, everything is right where you need it to be. Alright, let's look at another one. We have m over 3 plus m over 2 equals 20 over 3. In this situation, we don't have the same number, and so if we multiplied by 3, those two would cancel, but that wouldn't. If we multiply by 2, this would cancel, but those wouldn't. And this is where I talked about your common denominator or least common multiple. Ask yourself where 3 and 2 both meet, and of course they both meet at the number 6. And so 6 is what I would use. And then this is where you use your reducing part or your division part. 3 and 6 can both be divided by 3, turning this into a 2. And you take 2 times m, making this 2m. 6 and 2 both can be divided by 2, turning this into a 3. Here, multiplying that, you get plus 3m. 6 and 3 both can be divided by 3, turning this into a 2. 2 times 20 makes 40. There is one more mess, if you notice, and that is the fact that we have two variables on the same side that we must combine, getting 5m equals 40. And now notice it looks just like something we did last week, which most problems will. Divide both of those sides by 5, getting the answer of m equals 8. Alright, so in the first problem we had the same number on the bottom. It was easy to determine what to multiply by. It was 12. This one here, we had two numbers, so we had to find out where they meet. Same thing kind of here. H over 4 plus 3 over 5 equals 6. Again, look at the numbers on the bottom. 6 doesn't have a denominator, so we don't care about that. But we want to get rid of a 4 and a 5. Again, our messy situation here is the fractions. And so we get rid of the 4 and the 5 by multiplying by 20, because that's what 4 and 5 meet at, or where they meet. And again, we have to multiply every term the same. Now we follow that rule again. 4 and 20 both divided by 4 turns this into a 5, giving me 5h. 5 goes into 20 4 times, giving me 4 times 3, which is 12. 6 times 20, because there's nothing to combine with, makes 120. And again, notice this looks just like a question from last week, which is really what all of last week was about. That's why I worked you so hard, because I know that every question that you see from here on out is going to end up looking like something in that fundamental part that we worked on last week. So we subtract 12 from both sides, getting 5h equals, I think it's 108. Then we divide by 5. And again, if I were you and you're not good with fractions, I would just use my calculator to reduce it by typing it in and then pushing your math enter button to make sure that it ends up as 108 over 5. Now pay attention to the fact that sometimes a computer asks for a simplified fraction or a decimal rounded to a certain spot. If they wanted a decimal, you probably would have had to put 21.6, but just make sure you're reading what that problem is looking for. So what I want you to do is use the rest of this day to practice this skill on your Math XL. There is no lesson credit, but again, you should continue to still work on solving correctly by, I don't know what the words are saying here, by showing your steps. Otherwise, again, you're going to lose points on your assessments at the end of the week. So overall, last week was very methodical, very deliberate because of the importance of the steps. As I said, most of these problems, as you're going to notice, end up looking like a question from last week. This week we're going to speed it up a little bit, so just be sure to stick to the fundamentals and make sure you're asking questions. I still have people doing badly on their quizzes and doing badly in the class right now that I have not heard a question from in class, and you can't do that and survive at the same time. Again, if you don't want to ask questions, if the material is getting too tough, you might want to go talk to a dean about dropping down, because we are not going to slow down, and I would hate to have you fail this class just because your work ethic isn't appropriate for this level right now. I still feel like, again, people are struggling on their own and hoping that the problem will work itself out, which it won't. Remember the quote on my teacher page, insanity is doing the same thing over and over, expecting a different result. So if you think that you can fix it on your own, and over the last week or so, last 2 weeks of trying to fix it, it's still the same, make sure you make the necessary changes to find your successful range in this class. Other than that, go to Math XL and begin working on the assignment 2.3. Good luck.